good morning, good afternoon, or good evening to everyone tuning in from around the world. This is Alex Mercer, and today we're exploring a phenomenon that's happening beneath our very feet and above our heads every single moment of every single day. The astonishing speed at which our planet spins. It's one of those facts that seems almost impossible to grasp, because unlike a speeding car or a racing train, we don't feel the Earth moving at all. But here's the truth. Earth rotates around its axis at roughly 1,670 kilometers per hour at the equator. That's faster than a commercial jet, faster than almost anything we experience in daily life. And yet it goes completely unnoticed, because everything around us, the air, the oceans, the continents themselves, moves along in perfect harmony with this incredible spin. Imagine standing at the equator, racing around the planet at this mind-blowing speed, and still being able to sip your morning coffee without spilling a drop. That, my friends, is the quiet power of our spinning world. Now, consider for a moment what this rotation actually means. Every complete spin of Earth, roughly every 24 hours, gives us the rhythm of day and night. When one side of the planet faces the sun, it experiences daylight, while the other side, turned away, slips into darkness. This constant rotation creates a predictable cycle that life on Earth has synchronized with for millions of years. Plants open and close in response to sunlight. Animals hunt or rest according to the time of day. And humans, for better or worse, organize almost every activity around this 24-hour rhythm. Without Earth spinning at this exact pace, our world would be unrecognizable. Days could be longer or shorter, ecosystems might collapse, and life itself would have to adapt in ways we can only imagine. But the implications of Earth's rotation don't stop at day and night. They reach far into the natural forces that shape our planet. One of the most fascinating effects is the Coriolis Effect, which governs the movement of winds and ocean currents. Because Earth spins, air and water moving across its surface don't travel in straight lines. They are deflected, twisting weather systems and shaping storm patterns. Hurricanes swirl in different directions depending on their hemisphere because of this spin. Even the oceans, vast and seemingly endless, flow in large circular currents, influenced by the rotation of the planet beneath them. In other words, every storm you've ever seen on the news, every current that carries warm or cold water across thousands of miles, owes its existence, at least in part, to this incredible spin of Earth. Interestingly, Earth's rotation also has a subtle impact on geology. Scientists have found that changes in Earth's spin, tiny ones caused by shifting tectonic plates, melting glaciers, or massive earthquakes, can slightly affect the planet's axis and rotational speed. These changes are minuscule, often just fractions of a second, but they remind us that our planet is a dynamic system, constantly moving, constantly evolving. Even the very shape of Earth is affected. The planet is not a perfect sphere, but a slightly flattened one at the poles, bulging at the equator because of the centrifugal force created by its spin. That gentle but unstoppable motion influences tides, climate, and even how we measure time itself. Speaking of time, the spin of the Earth is directly responsible for our system of hours and minutes. The 24-hour day is a human construct, but it is perfectly aligned with the time it takes our planet to complete one full rotation. Time zones, daylight saving schedules, and even the way we plan flights and space missions all rely on this predictable motion. For instance, satellites in orbit are launched with the precise knowledge of Earth's rotation. They must move in sync with our spinning planet to maintain stable positions and accurate data collection. Every GPS signal you receive, every airline route mapped across continents, every scientific observation from space relies on this fundamental fact. The Earth is moving beneath us, fast, precise, and unrelenting. Now, let's put this speed into perspective. At 1,670 kilometers per hour at the equator, you are moving faster than a jetliner while sitting still. If you traveled along this imaginary equatorial highway for 24 hours straight, you could circle the Earth once without ever leaving the ground. As you move away from the equator toward the poles, that speed decreases, reaching nearly zero at the very top and bottom of the planet. So, depending on where you live, you're moving at different velocities, even though none of us feels a thing. This incredible reality challenges our intuition and makes one marvel at the sheer scale and precision of the cosmos. Historically, humans didn't always know the Earth was spinning. Ancient civilizations debated whether our planet moved or stood still, with many cultures believing the sun revolved around Earth. It wasn't until thinkers like Copernicus and Galileo began observing the heavens that we realized the truth. Earth rotates on its axis and orbits the sun. That realization revolutionized our understanding of the universe and laid the foundation for modern science. Today, the knowledge of Earth's spin underpins everything from astronomy to meteorology, reminding us that our everyday experiences, from sunrise to sunset, are all connected to a planet in constant motion. Finally, it's worth noting the profound philosophical implications of living on a fast-spinning world. Every step we take, every breath we draw, every moment we experience is happening on a planet hurtling through space at unimaginable speeds. It's humbling and exhilarating at the same time. The Earth's rotation is a silent partner in the story of life, shaping our environment, influencing our behavior, and reminding us that we exist on a planet that is dynamic, alive, and moving in perfect, unstoppable rhythm. So next time you look up at the sun or watch the moon rise, remember, beneath your feet, the Earth is spinning at incredible speeds, and we are all along for the ride, living in harmony with this magnificent cosmic motion. Have you ever stopped to consider why day and night occur so reliably, without fail, each and every day? This is not just a simple convenience. It is the result of the Earth's continuous, precise rotation on its axis. Every 24 hours, our planet completes a full spin, and it is this motion that determines which areas of the globe are bathed in sunlight and which fall into darkness. Imagine the Earth as a colossal spinning top, with one hemisphere facing the blazing sun while the other slips into shadow. The transition from day to night is seamless yet dramatic, an intricate dance that shapes life in ways we often take for granted. The speed of Earth's rotation dictates how quickly this transition occurs. A faster spin would mean shorter days and nights, while a slower spin would extend them, fundamentally altering the patterns of life that have evolved in synchrony with the planet's rhythm. Every sunrise and sunset we witness is the visible proof of this grand cosmic motion, reminding us that our world is alive and moving in a precise, predictable way. The effects of the Earth's rotation on day and night are most striking in the polar regions. Near the Arctic and Antarctic circles, the phenomena of the midnight sun and the polar night reveal just how extraordinary our planet's axial tilt and rotation truly are. During the summer months, the sun can remain visible for 24 hours straight, circling the horizon in a slow golden dance across the sky. Conversely, in winter, these regions are plunged into complete darkness for extended periods. These extreme conditions do not merely create dramatic visual experiences, they also influence entire ecosystems. Animals adapt their hunting and sleeping behaviors to cope with extended daylight or prolonged darkness. Plant life, too, responds to the extended exposure or absence of sunlight, regulating growth cycles and reproductive patterns according to the rhythm of the spinning Earth. Even humans, when traveling to or living in high latitudes, must adjust their daily routines to account for these dramatic shifts in daylight. The planet's rotation, therefore, is not just a mechanical motion. It is a key factor in the timing and organization of life on Earth. Beyond its impact on natural phenomena, the Earth's spin profoundly shapes human life and productivity. Our circadian rhythms, the internal biological clocks that regulate sleep, wakefulness, hormone production, and cognitive function, are closely aligned with the 24-hour cycle of day and night. Disruptions to this cycle, such as those caused by jet lag or shift work, can have significant effects on health and performance. From the rising sun signaling the start of a workday to the dimming light guiding us toward rest, the spinning Earth sets the tempo for human activity. Farmers, for instance, have historically relied on the consistency of sunrise and sunset to plan planting and harvesting schedules, while city planners and energy providers use daylight patterns to optimize lighting and resource use. Even modern technology, such as artificial lighting and automated systems, is designed with the predictable cycle of day and night in mind. In this sense, the rotation of our planet is not merely a celestial curiosity. It is the ultimate timekeeper, influencing everything from natural ecosystems to human society. The interplay between day and night also extends to cultural and philosophical dimensions. Across history, humans have celebrated the sun, created calendars, and structured religious practices around the predictable rhythm of sunrise and sunset. Festivals marking solstices, rituals timed to specific hours of daylight, and ancient navigational methods all reflect an intimate awareness of Earth's rotation. The planet's spin serves as both a scientific reality and a guiding framework for human civilization. It teaches us that life on Earth is inherently connected to the movement of our world, a reminder that while we may feel stationary, we are in fact participants in a continuous, planetary ballet that governs light, time, and life itself. Ultimately, the fast spin of the Earth is far more than a physical fact. It is a master clock, an invisible architect, and a force that shapes all living systems. Each day and night we experience is the direct result of this remarkable, continuous motion. As the sun rises over your horizon or sets in a blaze of color, take a moment to reflect on the incredible mechanics behind it. The Earth spins unceasingly, at speeds unimaginable to our senses, and yet it choreographs the rhythm of every heartbeat, the growth of every plant, and the activities of every human being. This is the profound and fascinating reality of life on a fast-spinning planet, a reality that connects us all to the cosmos in ways both subtle and extraordinary. Have you ever called a friend or colleague across the globe only to realize that while it's bright and sunny where you are, it's the middle of the night where they live? That daily experience is a direct result of the Earth's rotation and the creation of time zones. Our planet spins on its axis at approximately 1,670 kilometers per hour at the equator, and as it rotates, different parts of the globe receive sunlight at different times. This rotation is what gives us the familiar cycle of day and night, but more importantly, it also created the need for a standardized way to measure time across distances. Without this natural division, keeping track of hours, coordinating events, or even understanding when someone wakes up or goes to bed would be utterly chaotic. The concept of time zones is an ingenious human solution to a planetary problem. If we imagine the Earth as a circle divided into 24 equal slices, each slice represents a time zone, roughly corresponding to 15 degrees of longitude. As the Earth spins, the Sun reaches its highest point over each segment at what we call local noon. This system allows every region to maintain a relatively consistent relationship with the Sun. So when it is noon in London, the Sun is near its peak in the sky there, while it might be early morning or late evening across the Atlantic or in Asia. Understanding this is not just an abstract scientific fact. It's essential for practical daily life. From coordinating international business meetings to scheduling flights across continents, the rotation of the Earth dictates our very sense of time. Historically, timekeeping was far less standardized. Before the invention of time zones in the late 19th century, each city kept its own local time, usually determined by the sun's position. Noon in one city could be minutes ahead or behind noon in the next town. This system was manageable when travel was slow, but with the advent of railroads and telegraphs, such discrepancies became a problem. Train schedules were frequently delayed or confusing because each town had its own local time. It was Sir Sandford Fleming, a Canadian engineer, who proposed dividing the world into standardized time zones, creating a uniform system based on the rotation of the Earth. This innovation allowed societies to synchronize clocks, travel, commerce, and communication on a global scale. The effect of Earth's spin on time is also evident in phenomena such as the international date line. This imaginary line in the Pacific Ocean ensures that as we travel across longitudes, the calendar date adjusts to match the solar day. Without such systems, the simple act of crossing the globe could create confusion about what day it is. Even modern digital technologies, from scheduling software to GPS satellites, rely on precise calculations of Earth's rotation to keep time accurate. Our world is deeply dependent on understanding this constant spin, and it's a hidden rhythm that governs the very structure of global life. To make this more relatable, consider the modern global economy. A stock market opening in Tokyo, a trade meeting in New York, and a software deployment in London all happen in different time zones. Coordinating these activities without considering Earth's rotation and time zones would be impossible. Similarly, international flights are planned using precise time calculations based on time zones and rotational dynamics. Even when video calls connect colleagues across continents, the Earth's spin determines whether they meet at dawn, midday, or night. Understanding time zones is not just a matter of curiosity. It is the framework that allows our modern, connected civilization to function. Finally, it's fascinating to consider the psychological and cultural impacts of time zones. People in different regions live their lives in sync with daylight hours. Yet social, economic, and cultural activities adapt to these divisions in unique ways. For example, what is considered prime working hours in one country might fall outside of daylight hours in another. Festivals, prayer times, school schedules, and even sleep patterns are all influenced by the alignment of human activity with the Earth's rotation. By grasping how our spinning planet slices time across the globe, we gain a profound appreciation for both the science and the social fabric of our world. Alex Mercer here with a fascinating twist, literally. Today we're diving into a phenomenon that you experience every day without even realizing it, the Coriolis Effect. This is a direct consequence of the Earth's rotation, and it's responsible for shaping the winds, ocean currents, and even the behavior of massive storm systems like hurricanes. The principle is surprisingly simple, but its effects are enormous. Because Earth spins, any object moving freely above the surface, air, water, or even long-range projectiles, is deflected from a straight path. In the northern hemisphere, this deflection is to the right, while in the southern hemisphere, it is to the left. This twisting motion is the hidden hand behind much of the movement of our planet's atmosphere and oceans. The Coriolis effect explains why hurricanes spin differently depending on where they form. In the northern hemisphere, hurricanes rotate counterclockwise, while in the southern hemisphere, they rotate clockwise. Without the Earth spinning, wind and water would travel in straight lines, making the weather far more predictable, but drastically changing climates across the globe. Imagine a world where ocean currents didn't curve, where winds didn't spiral, and where storms lacked rotation. Such a world would look entirely different from the one we know. Entire ecosystems, from the Gulf Stream that warms Europe to the monsoon winds that feed crops in Asia, rely on this planetary spin. The origins of understanding the Coriolis effect are fascinating. Early scientists and navigators noticed that projectiles and ocean currents didn't behave exactly as expected when traveling long distances. It wasn't until the 19th century that French scientist Gaspard Gustave de Coriolis formalized the mathematics describing this effect. Today, meteorologists and oceanographers use it as a fundamental principle to predict weather patterns, model climate change, and even plan flight paths for long-distance air travel. Without accounting for the Coriolis effect, modern weather forecasting would be unreliable, and our understanding of hurricanes, cyclones, and ocean currents would be incomplete. The Coriolis effect also has practical consequences for human infrastructure and life. Engineers designing large-scale water systems, such as dams or aqueducts, must account for it. Pilots planning long flights and naval captains charting ocean courses need to consider the rotational deflection to avoid deviations. Even military operations historically factored this into artillery targeting over long distances. It's remarkable that a force generated by the invisible spin of Earth can have such tangible effects on daily life, commerce, and safety. Another fascinating aspect is the interplay between the Coriolis effect and climate systems. Jet streams, trade winds, and ocean gyres all owe their patterns to Earth's spin. The Gulf Stream, for instance, carries warm water from the tropics to northern Europe, moderating temperatures and supporting ecosystems far from the equator. Similarly, monsoon systems in India and Southeast Asia, critical for agriculture and human survival, are intricately linked to the rotation of our planet. The Coriolis effect isn't just a scientific curiosity. It is a governing principle of life on Earth, shaping everything from weather to global agriculture. Finally, consider the human experience of living in a world governed by this effect. Storm warnings, seasonal climate patterns, hurricane preparation, and even global trade are influenced by the spinning Earth. Every breeze you feel, every wave that reaches the shore, and every storm system swirling in the distance has its motion dictated by this invisible, yet powerful, rotational force. By understanding the Coriolis effect, we gain insight into the interconnectedness of our planet, seeing how the spin of Earth shapes the very patterns that sustain life. It's an extraordinary reminder that our world is not static. It's a dynamic, moving system, and every phenomenon we experience, from the calmest day to the fiercest storm, is connected to the relentless, unstoppable spin of the planet beneath us. When we think about space travel, rockets, and satellites orbiting high above the Earth, Most of us imagine them moving through empty space independently, but the reality is far more intricate. Every spacecraft we launch must account for the Earth's rotation. Our planet is spinning beneath us at incredible speeds, about 1,670 kilometers per hour at the equator, and engineers use this motion to their advantage every time a rocket leaves the ground. By launching eastward, rockets gain an extra boost from the rotational speed, reducing fuel requirements and allowing spacecraft to reach orbit more efficiently. This is why launch sites near the equator, like the Guyana Space Center in French Guyana, are so strategic. They capitalize on the planet's natural momentum, essentially hitching a ride on the Earth's spin. The rotational speed of Earth also affects the trajectories of satellites once they are in orbit. A satellite in low Earth orbit does not simply float stationary above the planet. It must match the Earth's spin to maintain its path relative to the surface. Engineers calculate minute adjustments in real time, accounting for the planet's rotation, gravitational forces, and orbital decay. Every second, the Earth moves beneath these satellites, and every calculation ensures they stay in sync with their intended path. It's a dizzying cosmic dance between technology and the relentless spin of our planet. Without understanding this, satellite positioning for GPS, communications, weather monitoring, and even international space stations would be unreliable. Consider the example of GPS satellites. These satellites provide accurate positioning for navigation, aviation, and maritime travel. However, because the Earth spins, a satellite's signal must account for the movement beneath it. Engineers must synchronize the satellite's orbit with the planet's rotation so that, at any moment, a GPS receiver on the ground receives precise coordinates. A tiny miscalculation could result in errors of hundreds of meters, which is unacceptable when airplanes, ships, and emergency responders depend on it. Similarly, communications satellites rely on geostationary orbits, hovering over a fixed point on the equator. To maintain this position, they must move at the same rotational speed as the Earth itself. The history of space exploration also illustrates the critical importance of Earth's spin. Early rocket pioneers discovered that launching eastward provided a significant velocity advantage. During the Apollo missions, for example, calculations of Earth's rotational boost were essential to slingshot rockets efficiently toward the moon. Today, the same principle applies to launching satellites into geostationary orbit, sending probes to Mars, and even planning future missions to asteroids. Every mission is a testament to human ingenuity, leveraging the unseen motion of our fast-spinning planet to reach farther than ever before. Beyond practical advantages, the Earth's rotation creates fascinating challenges for space travel. Even slight changes in the planet's speed, caused by tidal forces, glacial melting, or seismic activity, can affect long-term satellite orbits and timing calculations. Scientists continuously monitor these changes to ensure that satellites maintain accuracy over years and decades. From weather forecasting to telecommunications, our modern infrastructure depends on the precise understanding of the Earth's spin. In short, space exploration is not just about rockets and engines. It's a delicate, ongoing conversation with a planet that never stops moving. A reminder that our technologies are intimately tied to the natural rhythms of our world. Many people wonder whether the speed at which Earth spins could influence natural disasters such as earthquakes. While it may seem intuitive that a faster rotation could somehow shake the planet, the relationship is far more subtle and fascinating. Scientists have studied the interplay between rotational speed, mass distribution, and the behavior of Earth's crust. And while spinning fast doesn't directly cause earthquakes, it does have indirect influences that reveal just how interconnected the planet truly is. The Earth is a dynamic system, and its rotation affects everything from ocean currents to atmospheric patterns. When massive events like earthquakes occur, they can actually influence the planet's rotation, albeit in extremely small increments. For example, the 2011 Tohoku earthquake in Japan, one of the largest ever recorded, shifted the mass of the Earth enough to slightly alter the length of a day by microseconds. Such shifts are imperceptible in daily life, yet they demonstrate that Earth's spin and its geological processes are not independent. They are deeply intertwined. Even the slightest redistribution of mass, whether from an earthquake, volcanic eruption, or glacial melt, can adjust rotational speed and affect the orientation of the axis. Understanding these subtle links is essential for geophysics and earthquake research. Scientists use high-precision satellites and instruments like GPS and gravimeters to monitor how the Earth's spin interacts with tectonic movement. This helps in modeling how stress builds up along fault lines, and in predicting how large-scale seismic events might redistribute mass and energy. It is a remarkable example of the interconnectedness of our planet. Motion in one system, such as rotation, affects another system, such as tectonics, which in turn may feed back to influence rotation. Earth's rotation also plays a role in the distribution of forces across the planet. The centrifugal force created by the spin is greatest at the equator and diminishes toward the poles. While this force is small relative to tectonic stress, it subtly influences the stress patterns in Earth's crust. Some researchers hypothesize that long-term changes in rotational speed, due to factors such as tidal interactions with the Moon, could influence the frequency or location of seismic activity over geological timescales. Even if these effects are small, they are part of the intricate web of forces that maintain the balance of our planet. Moreover, the interplay between Earth's rotation and geological processes reminds us that the planet is not static. It is alive in motion, constantly adjusting, shifting, and responding to internal and external forces. From a philosophical standpoint, it is humbling to consider that the Earth we inhabit is both spinning at incredible speeds and undergoing constant internal stress, yet life persists. Earthquakes are dramatic reminders of this ongoing activity, while the planet's rotation provides a stabilizing, predictable rhythm. In studying these phenomena together, scientists gain insight into the resilience and complexity of our world. In conclusion, while a fast-spinning Earth doesn't cause earthquakes directly, the relationship between rotation, mass distribution, and tectonic activity is a fascinating demonstration of planetary interconnectedness. Every seismic tremor, every subtle shift in mass, every tiny adjustment in rotational speed is part of an immense, ongoing conversation within the Earth itself. By understanding these forces, we not only learn more about natural disasters, but also gain a deeper appreciation for the delicate balance that sustains life on a dynamic, spinning planet. It is a reminder that our home is a living, moving system, and every motion, seen or unseen, shapes the world we inhabit. Most of us go through life without a second thought about the planet spinning beneath us. Yet the Earth's rotation exerts a profound influence on every human being in ways we rarely notice. One of the most fascinating effects is on our sleep patterns, which are governed by what scientists call the circadian rhythm. This is a natural 24-hour cycle that regulates sleep, wakefulness, hormone production, body temperature, metabolism, and even cognitive performance. The circadian rhythm is intimately tied to the rising and setting of the sun. a direct consequence of the Earth completing a full rotation every day. In essence, each heartbeat, each moment of alertness, and each urge to sleep is subtly synchronized with the planet's spin. When this rhythm is disrupted, whether by traveling across multiple time zones, working night shifts, or exposure to artificial lighting, the effects are noticeable. Jet lag is the most familiar manifestation. It is your body's internal clock struggling to recalibrate to a new alignment with the sun. Symptoms such as fatigue, irritability, digestive disturbances, and impaired cognitive function occur because your circadian rhythm remains temporarily tied to your original time zone. Even the slightest misalignment, like staying up an hour later than usual, can trigger a cascade of effects on hormone secretion, alertness, and mood. This demonstrates that humans are not separate from the Earth's rotation. We are profoundly linked to its 24-hour cycle, living in harmony, or sometimes conflict, with a planet that spins at over 1,600 kilometers per hour beneath our feet. The impact of Earth's spin extends beyond individual sleep cycles. It shapes entire patterns of human behavior and productivity. Early civilizations relied heavily on daylight to structure their lives. Farmers planned planting, harvesting, and irrigation around the predictable arrival of sunrise, while city dwellers organized markets, work schedules, and religious rituals according to the movement of the sun. Even in modern urban life, artificial lighting cannot fully replicate the effects of natural sunlight on our biology. Studies have shown that exposure to daylight, or the lack thereof, affects mood, mental health, and overall well-being. Seasonal affective disorder, for example, occurs in higher latitudes where extended periods of darkness disrupt the natural circadian rhythm. Beyond health, the relationship between the Earth's spin and human activity manifests in social and economic rhythms. Global work schedules, international travel, and even digital communication are designed around the predictable cycles of day and night. Energy consumption peaks during daytime, while cities sleep at night, reflecting our alignment with the spinning planet. Our biological clocks, societal schedules, and technological systems all operate in tandem with this underlying rhythm. Even small changes, such as daylight saving time, provoke discussion and controversy because they temporarily shift human activity out of alignment with the Earth's natural rotation. From a broader perspective, understanding the connection between human life and the Earth's rotation provides insight into our adaptation as a species. Humans have evolved to anticipate the predictable light-dark cycle, and our survival has historically depended on this synchronization. Today, we manipulate light, schedules, and work patterns to extend our days, but our biology still resonates with the fundamental 24-hour cycle. Every yawn, every surge of energy, and every restful night is tied to this ancient, invisible rhythm, a constant reminder that we live on a fast-turning planet that shapes our bodies as much as it shapes the environment around us. In short, the Earth's rotation is far more than a scientific fact. It is a hidden director of human biology and behavior. Every second of alertness, every moment of sleep, every pattern of work or leisure is intimately connected to this daily cosmic motion. Recognizing this connection deepens our appreciation of the remarkable harmony between life and the spinning world beneath our feet, reminding us that we are participants in an intricate dance with a planet that never stops moving. Long before satellites, precise clocks, and modern astronomy, humanity grappled with one of the most fundamental questions about our world. Does the Earth move, or does it remain stationary while the heavens revolve around it? Ancient civilizations, from the Greeks to the Babylonians, offered a variety of theories. Some imagined the Earth as a flat, immobile platform, while others believed it was a sphere that stood still at the center of the universe. For centuries, the idea of a spinning Earth seemed inconceivable. Observations of the sun, moon, and stars appeared to support a geocentric model in which all celestial bodies revolved around a fixed Earth. This belief was deeply ingrained, influencing philosophy, religion, and early science. The revolution began during the Renaissance with thinkers like Nicholas Copernicus, who proposed that the Earth was not the center of the universe, but rather rotated on its axis and orbited the sun. This heliocentric model was revolutionary, not just scientifically, but culturally and philosophically. Copernicus suggested that the Earth's rotation explained the apparent motion of the sun, moon, and stars across the sky. It was a radical shift in perspective. Humans were no longer at the center of the cosmos, but observers on a spinning planet, moving through space along with countless other celestial bodies. Galileo Galilei further advanced this understanding through careful observation and experimentation. Using telescopes, he documented the moons of Jupiter, the phases of Venus, and countless other phenomena that contradicted the geocentric view. Galileo faced fierce opposition from authorities who saw these ideas as heretical, yet his work laid the foundation for modern astronomy. Later scientists, including Johannes Kepler and Isaac Newton, built on this knowledge, formalizing the laws of planetary motion and the physics of rotation. Every rotation of the Earth, then, is a silent testament to centuries of human curiosity, debate, and discovery. The historical debate over Earth's rotation also highlights humanity's evolving relationship with knowledge. For thousands of years, humans relied on observation, tradition, and philosophical reasoning to interpret the world. Gradually, empirical evidence, mathematics, and technological innovation allowed us to move beyond intuition and superstition. Today, we measure Earth's rotation with atomic clocks, satellites, and lasers, achieving precision that ancient civilizations could scarcely imagine. Yet, every sunrise and sunset remains a connection to the same fundamental motion that early astronomers struggled to understand. Even culturally, awareness of the Earth's spin transformed human thought. It altered calendars, navigation, and timekeeping. Sailors could chart courses across oceans. Astronomers could predict celestial events with accuracy. And philosophers could reconsider humanity's place in the universe. The realization that Earth rotates on its axis shifted our perspective from a stationary, Earth-centered worldview to one of motion, scale, and interconnection with the cosmos. Every scientific discovery, every orbiting satellite, and every sunrise we witness today is rooted in the centuries-long journey to understand this simple yet profound fact. The Earth is spinning. Finally, reflecting on the history of our understanding of Earth's rotation reminds us of the enduring power of curiosity. From ancient scholars debating the motion of the stars to modern scientists calculating precise rotational speed, humans have sought to understand the invisible forces shaping our world. Today, every turn of the planet beneath our feet is a living tribute to the ingenuity, persistence, and courage of those who challenged assumptions and dared to see the world differently. Recognizing this history deepens our appreciation for the spinning Earth we inhabit, and for the remarkable journey of discovery that continues to expand our knowledge of the cosmos. Imagine for a moment that the Earth suddenly changed its rotational speed, spinning faster or slowing down. What would that mean for life as we know it? The idea might seem like science fiction, But exploring this scenario reveals just how finely tuned our planet's rotation is. If the Earth spun faster, days would become shorter. Our 24-hour cycle would shrink, and the centrifugal force generated by the increased spin would be stronger. This would cause the planet to bulge even more at the equator, subtly altering the shape of oceans, shifting coastlines, and affecting weather systems. Currents, wind patterns, and even the Coriolis effect that dictates storm rotation would be impacted. Life itself, adapted over millennia to a predictable 24-hour day, would face a profound challenge. Conversely, if the Earth spun more slowly, days would stretch longer. Nights and days could last more than 24 hours, disrupting circadian rhythms, agriculture cycles, and energy consumption patterns. The reduction in rotational speed would weaken the Coriolis effect, leading to changes in wind and ocean currents. Hurricanes might behave differently, ocean gyres could shift, and weather patterns across the globe would be altered. Such changes would ripple through ecosystems, agriculture, human societies, and even long-term climate systems. While these scenarios are extreme, subtle shifts in rotational speed do occur naturally over millennia. Tidal interactions with the moon, for example, gradually slow Earth's rotation at a rate of approximately 1.7 milliseconds per century. Over millions of years, this has lengthened days and subtly reshaped life on our planet. This thought experiment underscores the incredible balance that sustains life. The Earth's current spin is neither too fast nor too slow. It is a dynamic force that maintains climates, currents, and cycles in a stable equilibrium. Understanding shows how the rotation interacts with the planet's shape, oceans, and atmosphere reminds us that we are living on a finely tuned system. Even tiny shifts can have large consequences, and the planet's stability is both remarkable and humbling. To truly appreciate the Earth's rotation, it helps to compare it with other planets in our solar system. Take Jupiter, the gas giant, for example. Despite being over 11 times wider than Earth, Jupiter completes a full rotation in just about 10 hours. Imagine standing on a giant spinning ball of gas moving that quickly. The forces at play would be staggering. The rapid spin of Jupiter contributes to its extreme weather patterns, including the Great Red Spot, a storm larger than Earth itself, which has persisted for centuries. The rotation of a planet fundamentally affects atmospheric dynamics, weather systems, and the distribution of heat, giving each world its unique personality. Mars, on the other hand, spins at nearly the same speed as Earth, with a day lasting just 24 hours and 37 minutes. This similarity in rotational speed has significant implications for the planet's environment and, potentially, for future human exploration. Scientists study Mars's spin and its effects on weather and climate to better understand how life could exist or be sustained there. By comparing planetary rotations, we gain insight into why Earth is so uniquely suited for life as we know it. Its moderate spin stabilizes climate patterns, regulates day-night cycles, and supports complex ecosystems. The contrast with planets like Jupiter or Mercury, which spins far more slowly, highlights how rotation shapes everything from storms to habitability. Considering these planetary extremes also helps us appreciate the delicate balance of forces that sustain life on Earth. Rotation is not just a curiosity, it's a fundamental property that determines weather, climate, and even the potential for life. When we look at other planets, we see worlds shaped by rotation in ways both dramatic and subtle, reinforcing just how extraordinary Earth's spin truly is. And now for a segment designed to make you marvel at the spinning planet beneath your feet. Spin Trivia. Here's a fascinating thought. If you could travel along the equator at Earth's rotational speed, roughly 1,670 kilometers per hour, you would circle the planet in just 24 hours. Think about that. The same 24 hours that we experience as a single day would allow you to complete an entire journey around the globe, all while remaining on the ground. The experience of spinning, of course, depends entirely on your location. At the poles, rotational speed is nearly zero. You could, theoretically, stand still while the equator races by thousands of kilometers per hour beneath you. This difference in speed also explains the equatorial bulge. The Earth is slightly flattened at the poles and wider at the equator due to centrifugal forces caused by rotation. That means the planet you inhabit is not a perfect sphere. It's a dynamic, spinning world shaped by forces that stretch from core to crust. Even satellites and GPS systems must account for this bulge and the Earth's rotation to maintain precise navigation. Every rotation is a dance of cosmic precision, invisible to our senses, but omnipresent in its effects. Here's another fun twist. The speed of Earth's rotation has subtly slowed over geological time due to tidal interactions with the Moon. Millions of years ago, days were much shorter, some lasting just 22 hours. Over time, the delicate push and pull between Earth and Moon have gradually lengthened the day to the 24-hour cycle we know today. It's amazing to consider that every sunrise we see, every sunset we admire, is part of an ancient rhythm shaped by gravity, motion, and the inexorable spin of our planet. Finally, the sheer precision of Earth's rotation is astounding. Despite variations in climate, earthquakes, or atmospheric changes, the planet maintains a nearly perfect 24-hour day. This constancy underpins timekeeping, life cycles, and even technological systems like satellites and communications networks. Earth's spin is, in a very real sense, the invisible conductor of life itself, shaping every heartbeat, every storm, and every ocean current. By understanding it, we gain insight not only into the mechanics of our world, but also into the delicate interplay of forces that make life on Earth possible. Every time you pull out your phone or check your car's navigation system, you probably take it for granted that the directions are accurate. But behind that simple interface lies a complex interplay of physics, technology, and the Earth's own rotation. The Global Positioning System, or GPS, is not just floating in space as a passive observer. It is constantly calculating, adjusting, and compensating for the fact that the planet beneath it is spinning at over 1,600 kilometers per hour at the equator. Every satellite orbiting the Earth must account for this motion in order to deliver precise location data. Without this crucial consideration, your navigation apps would be wildly inaccurate, especially when traveling long distances, crossing continents, or navigating at high speeds. To understand why, let's consider how GPS works at a fundamental level. GPS satellites continuously broadcast signals that include the time and their precise position in orbit. A receiver on the ground, your phone, smartwatch, or car navigation system, calculates the distance to several satellites based on the time it takes for these signals to arrive. Using triangulation, it pinpoints your exact location on the Earth's surface. Now here's where the rotation of our planet complicates matters. The ground you're standing on is moving as the Earth spins. If the satellites didn't account for this movement, the calculated position would lag behind reality, creating errors that could range from meters to kilometers. Engineers and scientists have developed sophisticated algorithms to correct for the Earth's spin, ensuring that the GPS signal remains accurate and reliable. The importance of accounting for Earth's rotation becomes even more evident when considering high-speed travel. Airplanes, ships, and even rockets rely on GPS for navigation, and small errors can have significant consequences. For instance, a commercial aircraft flying across the Atlantic could easily end up hundreds of kilometers off course without precise correction for the planet's motion. Similarly, ships navigating busy waterways or attempting to dock at ports rely on highly accurate GPS coordinates. The spinning Earth is an invisible factor, yet every journey depends on its effects being incorporated into technology. The history of GPS development highlights just how intricate this problem is. The system was originally created by the U.S. Department of Defense, with the first satellites launched in the 1970s. Engineers quickly realized that to achieve the precision required for both military and civilian applications, they had to account not only for the speed of the satellites and relativistic effects predicted by Einstein, but also for the fact that the Earth itself was in constant motion. This combination of rotation, orbital mechanics, and the finite speed of light makes GPS one of the most remarkable technological achievements of the modern era. Each time your device gives you turn-by-turn directions, it reflects decades of calculations and innovations that harmonize human technology with the natural rhythm of our spinning planet. The effect of Earth's rotation on GPS is not static either. Variations in rotational speed, caused by tides, earthquakes, or shifts in mass distribution, must be continuously monitored and updated in satellite algorithms. Even small changes, measured in milliseconds, can impact accuracy over long distances. Scientists use atomic clocks, laser ranging, and ground monitoring stations to track these tiny adjustments in real time. The result is a system that seamlessly integrates the dynamics of our moving planet into everyday life, allowing us to navigate cities, oceans, and even other planets with confidence. Beyond navigation, the synchronization of GPS with Earth's rotation has profound implications for society. Financial systems, telecommunications networks, emergency response operations, and even power grids rely on precise timing coordinated with the Earth's spin. Every transaction, phone call, and energy distribution event is indirectly tied to the rotation of our planet. In a very real sense, humans have built an invisible infrastructure that dances in harmony with a planet that never stops moving. By understanding and compensating for the spinning Earth, we have created a technological system that interacts with natural motion in ways that would have been unimaginable just a century ago. Finally, it is humbling to consider that every time you glance at your GPS, check directions, or track a delivery, you are participating in a complex interaction with the physics of our world. The satellites above, the signals transmitted, the calculations performed, all are designed to accommodate a planet in motion. The Earth spins relentlessly, silently, invisibly, and human technology has risen to meet this challenge, turning an invisible natural phenomenon into a practical, everyday tool. Each accurate turn-by-turn instruction is a reminder of the hidden mechanics of our planet and our ability to adapt, innovate, and harmonize with the dynamic world we call home. Welcome back, listeners. Today we're closing out our incredible journey through the hidden forces of our spinning planet with a truly interactive and mind-bending segment I like to call the Spin Challenge. Now, I want you to really engage with me here. Imagine standing anywhere on Earth, feeling completely stationary, yet beneath your feet, the planet is moving at breathtaking speeds. You might be sipping your morning coffee, jogging in the park, or even stuck in traffic, and all the while, Earth is spinning, carrying you along silently and invisibly. The spin challenge asks a simple question. If you're standing at 45 degrees latitude, roughly halfway between the equator and the poles, how fast are you moving along with the planet? Take a moment to think about it. The hint: it's slower than at the equator. This difference in speed isn't random. It's a result of the geometry of a rotating sphere. At the equator, the circumference of the Earth is the largest, and so the rotational speed reaches its maximum, about 1,670 kilometers per hour. As you move toward higher latitudes, closer to the poles, the distance you travel around the Earth during one full rotation decreases. By the time you reach 45 degrees latitude, that slice of the planet's spin carries you along at roughly 1,180 kilometers per hour. And as you approach the poles, the speed drops to nearly zero. It's a fascinating reminder that the same planet can be experienced differently depending on where you are. Standing on the equator is like riding a cosmic conveyor belt at full throttle, while the poles offer a nearly stationary view of the spinning world. But this is not just a fun bit of trivia. It has real implications. Aviation, for example, depends heavily on understanding Earth's rotational speed. Pilots planning long-distance flights must consider how the rotation affects air movement and wind patterns, especially for precision navigation near the poles versus the equator. Similarly, meteorologists account for latitude-specific spin speeds when modeling climate systems, predicting hurricanes, or calculating the movement of ocean currents. Even GPS satellites, which we explored in detail in a previous episode, must adjust their signals based on your position on the planet. Every calculation, every model, every prediction incorporates this invisible but critical motion. Let's make this more relatable. Imagine you are flying from New York to London. Your plane travels hundreds of kilometers per hour relative to the surface of the Earth, but the Earth itself is spinning beneath you. While you may think of your speed purely as the plane's movement, your actual path through space combines both your velocity and the rotational velocity of the planet. This interaction subtly affects flight planning, fuel consumption, and arrival times. It's mind-boggling to realize that, while you might feel motionless sitting in your seat, the planet beneath you is moving faster than any vehicle we can build. That's the reality of living on a spinning sphere. Now, let's turn to a fun thought experiment. Suppose you could somehow see yourself from space as Earth rotates. At the equator, you'd be moving almost 1,700 kilometers per hour, watching continents slide past beneath you. At 45 degrees latitude, you'd still be racing along at over 1,100 kilometers per hour, but the apparent motion of the horizon would be slower. And near the poles, you could imagine standing almost still, with the spinning world rotating around you. This visualization helps us grasp the scale and precision of Earth's motion, a force so constant that we rarely notice it, yet so powerful that it shapes the climate, the oceans, and even our daily lives. Here's the challenge I want for you listeners. Next time you step outside, take a moment to imagine your own speed relative to the spinning planet. Whether you're at the equator, mid-latitude, or near the poles, you are moving with Earth at incredible velocity, faster than a jet, faster than any bullet train, yet completely imperceptible. Think about your morning routine, your commute, even your leisure activities, and remember that every movement is happening on a fast-moving, spinning world. The spin challenge is not just about numbers, it's about perspective. It's a reminder of our place in a dynamic universe, and the silent, invisible forces that make life possible. But let's take it a step further. Consider how this rotation interacts with daily life beyond your individual movement. Your circadian rhythm, sleep cycles, and productivity are influenced by the daily rotation of Earth. Weather systems, winds, ocean currents, and even jet streams are affected by rotational speed at your latitude. So when you feel the wind on your face, watch clouds drift, or experience a sudden storm, part of that natural rhythm is governed by the spin of the planet. Each of us, every day, is living in synchrony with Earth's movement, whether we notice it or not. Finally, the spin challenge is also about imagination and curiosity. I encourage you to share it with family and friends. Did you know that right now I am moving over 1,100 kilometers per hour just because of the Earth spinning beneath me? It sparks wonder, engages the mind, and deepens appreciation for the intricate mechanics of our world. Science isn't always about equations or complex instruments. Sometimes it's about perspective, about realizing that even the most mundane moments, sipping coffee, walking to work, or gazing at the sky, are intertwined with forces moving at cosmic scale. So listeners, the next time you step outside, pause for a moment. Imagine yourself riding on a fast-moving, invisible carousel spinning at thousands of kilometers per hour. Feel the Earth beneath your feet, spinning relentlessly and silently. Whether at the equator, 45 degrees latitude, or near the poles, you are part of an incredible cosmic dance, a rhythm that has existed for billions of years and will continue long after we are gone. That's the true wonder of the Spin Challenge. It connects us all, across continents and latitudes, to the invisible, magnificent motion of our planet. And with that, we conclude our 13-part exploration of the Earth's spinning mysteries. I hope this journey has opened your eyes to the hidden forces beneath our feet, above our heads, and all around us. Remember, life on Earth is a dynamic, moving experience, literally. Keep wondering, keep observing, and never forget that every step you take is part of a fast-turning, incredible world. This is Alex Mercer, thanking you for riding along on the cosmic spin with me. And that's a wrap, listeners. Thank you for joining me, Alex Mercer, on this whirlwind journey through the spinning mysteries of our planet. From the equator to the poles, from satellites in orbit to the rhythm of your own heartbeat. We've seen how Earth's rotation shapes every part of life. Keep looking up, keep wondering, and remember, you're riding on a fast-turning, incredible world every single day. Until next time, stay curious and keep spinning with the planet.